All right. Good morning, good evening, good afternoon to you all. My name is Gloria. I'm part of the Get Coin events team, and I'm here with Hugo and Cullum from LUKSO, and we are going to go over a little bit of the tools during this workshop. But before we get started, I wanted to take care of a little bit of housekeeping. First and foremost, this session is being recorded, so you can take a look at this session and all the previous sessions on the Get Coin Media YouTube channel. There should be a playlist specifically for this hackathon, and so if you do need to rewatch any of this video or the previous videos, you can go ahead and do so. Second of all, if you have any questions, feel free to drop it either in the chat or the Q&A. If you're watching on YouTube, you can drop it in the chat there as well, and I will make sure that your questions get answered. Last but not least, feel free to say hi in the chat. Let us know what you are working on and where you are watching from. It's a great way for us to get to know all of y'all, and it's a great way for y'all to get to know one another. With that, I'll go ahead and hand it over to Hugo and to Cullum, and we can get started.
Cool.
Hi, cool. Thanks. Yeah,
excellent.
Cool. Callum, you go first.
Cool. Yeah, welcome to this workshop for our LUKSO Build Up Hackathon tools. Yeah, welcome. So just as introductions, my name is Callum. I'm a software engineer at LUKSO. I've been on the team for about over a year now, working on some of the backend services and JavaScript libraries that we will display in this presentation.
And I'm Hugo. I joined the team like 2 years ago, and I'm working very closely with Callum on all those like NPM packages, backend services, and also like helping the communities. So yeah, today we'll present to you what we've been working on and how those tools can help you in building stuff with the LUKSO standards. Cool.
Cool. Yeah, so just before we get into it, I just want to highlight we've got documentation at docs.lukso.tech. I would always advise going and checking things out here. We put a lot of effort into writing these and trying to make these clear for you as developers. So yeah, please use them, and also please give any feedback if you think things could be better or clear, because they're supposed to be readable and useful. And if they're not, we want to do things better. So. Cool. So for this workshop, we're going to go over 4 main tools. We'll talk about ERC725.js and lsp-factory.js, which are 2 of the JavaScript libraries we've developed, and then go over Relayer API and ERC725 Inspect, which are, so the Relayer you can use to execute transactions for your universal profiles, and ERC725.js Inspect is a debugging tool you can use for your smart contracts, and then we'll have a coding demo as well. So to get into ERC725.js, what is ERC725.js? So this library, the goal is, so to save data on an ERC725Y smart contract, the data needs to be encoded in a particular format so it can be stored. So smart contracts like bytes, that's what you can save on smart contracts. So we need a way of encoding our values, which are human readable, into something which is smart contract readable. The problem is we need a standardized rule set to enable decoding and encoding, so everyone knows the same rules, so everyone can use the same rules to encode and decode, so everyone is able to read the same data. So LSP2 is a standard which we've developed. So we can use, and this enables everyone to have the same rules of decoding. So without ERC725.js, if a developer was to come along and try and decode this is the type of thing you might expect. This is the kind of thing which developers don't like to see. This isn't what people are going to be putting in their code. And it's going to scare developers away. So the goal is with ERC725.js is to make this process really easy and it abstracts all of that complexity away from developers, and just they can do it in 1 line of code. So go to the next slide. So with ERC725.js, this is more what we can expect in our applications, which is obviously a lot nicer to look at. So yeah, so ERC725.js removes all of the complexity of encoding data to save on ERC725Y smart contracts. And we want this to be as easy as making HTTP requests. So For most developers, very few, I think, will be making manual HTTP requests in their applications. Most are going to be using libraries like Axios and Fetch, the Fetch API, in order to make their HTTP requests. And this makes it really easy. And the exact same is true of saving data on smart contracts. We think that libraries are going to make this easier for developers, and this is how we onboard developers and make it as easy as possible to make decentralized applications that interact with smart contracts. Cool. So,
Callum?
Yes.
Okay. Yeah, I think I have the control over the slides, so just let me know if you
Sure,
want
I'll
me
let
to
you know.
change.
I think my side broke. Cool.
Yeah, it's
Thanks. So the way the ERC725Y works is it's using these the LSP2 standard. We use schemas, and you can think of these schemas as like a rule set, and it's a rule that we use to encode and decode data. So we pass these into ERC75JS in order to tell ERC75JS how our data should be encoded and decoded. And all applications can follow the same rules. These are universal. So any application that wants to fetch some data can choose the rules they need, and they can use those rules to fetch the data and encode it. You can go to the next one. Cool. So here we've got the same example. This is the schema for LSP3 profile, which is a metadata standard. And to use it in the ERC75JS, what you do is you can pass this schema straight into the schemas array during instantiation. So you can pass multiple of these schemas all at once when instantiating, whichever ones you need and that you're going to use in your application to encode data or to decode data. And even if you don't even need to know the details of what is in those schemas, because if you don't want to have to think about that, that's beyond what you want to dig into, you can just import these schemas as well from ERC75JS. The most common ones, so the ones which are described by our LSP standards, you can import these from ERC75JS. So for example, here, this code is the exact same that we saw on the previous slide. The only difference is here, I'm importing the LSP3 schema from the ERC75JS library and passing it into our ERC75JS instance. Cool. So the way that this works, once we set up ERC75JS and we've got our instance and we've passed in our schema, and we want to encode our data. So here in this example, I'm using the lsp token name schema. And here I've passed this into the instance. And then when I encode the data, I simply do ERC75.encode data. And we specify which schema we want to use, or you can think of this like which rule set we want to use to determine how the data should be encoded by passing the key name parameter inside the object. So here we've got key name, lsp token name. This corresponds to the name property on the schema. So we're telling ERC75JS to encode our value, which is my code token, using this particular schema. And ERC75JS is going to encode it using that particular rule set. Good. Yeah. So now we can see the result of this in the comment below. So we've done ERC75.encode data, and the comment, we get an object with just keys and values. So it's going to give us an array, which is the key, and the value. So the key is the location of where we're going to save the value on the ERC75Y smart contract. So if another developer was to come along and they want to be able to read this value, they can use the same key to get that data and pull it from the smart contract to read it. And this is already set up so that it can easily be passed into ERC75Y contracts. So the ERC75Y contract, it has a function get data and set data. And the set data function expects two parameters, keys and values. And ERC725JS, the return values it's going to give you back are set up so that they're just, there's no more processing needed. You can just pass them straight back into the set data function. So here we've got the same example, encoding my lsp token, and the result I'm just going to pass straight into set data. So we do my token contracts.set data, pass in encoded data.keys and encoded data.values. So once we've done that, our data has now been transformed in 2 ways. So first, it can now be saved on the smart contract. So originally we had a string, which was Michael token. This was transformed into a way which was readable by smart contracts and can be saved on the smart contract, which is bytes. Smart contracts always deal with bytes. That's what the type of data they like. And second, and importantly, that value, because it's following the LSP2 schema, which is a common schema that everyone knows, anyone who comes along can also decode those bytes. So even though the data has been transformed from a way which is human readable into a non-human readable way, which is bytes, they can go the other way around. So anyone who wants to read this data can use the exact same rules schema to decode it and get the same value I set on the smart contract. This gives us like a common language which we can use when interacting with smart contracts, which means that everyone can save data on the smart contract. As long as we know the rules that are being used when encoding the data, anyone can read that data as well. And using libraries like ERC725 this makes the barrier to entry very low, because we want this to be as easy as possible for new developers to come on who maybe haven't like dug into these schemas fully yet. They should just be able to dive right in and start writing and setting data on smart contracts. You can move on. Cool. So now we've set the data on our ERC725Y smart contract. We want to go the other way around. So if we imagine I'm now a client who wants to read this data from some smart contract, the data is in a way which is not human readable. You see, first on the left, we've got your ERC725Y smart contract, all these numbers and symbols, like humans don't like that. This isn't no good in your application. So we use ERC725.js using our rule sets that we've defined in the schema to decode this. And this gives us some values which is actually useful for an application. And actually is going to be good to display to users who are using your applications and projects. So to decode data using ERC725.js, we do the exact same thing that we do to encode in reverse. So here in this example in line 1, this is where I'm fetching the data. So I'm fetching the data which was set on the smart contract using this key. I'll talk more about how we can generate keys in a moment, but for now we can just say this is the same key that I used to set this data on the ERC725 smart contract. So I can call my token contract.get data pass the key. And the return value that it's going to give me is going to be the encoded value that has been stored on the contract. This isn't good for humans to read, so we need to decode this. So we do ERC725 decode data, and in our object here, the way we can decode is we specify the rules that we want to decode, which is lsp-factory token name. This is how we say that these values should be decoded, and the value we want to decode is the bytes we got from the token contract. And in this case, the result you can see here, the name, the key, and the value is my code token. So we've gone right the other way back around. So we've encoded our data, set it on the contract, fetched the data from the contract, and decoded it back into a value which is useful and going to be usable in applications. Cool. So that example was fairly simple, fairly straightforward in the sense that it's just encoding a string value. And it's going to be a static value, not going to change. Sometimes we want more complex data types. For example, we might have a key, which is going to depend on some variable, which might change. And in that case, we don't necessarily know what the key is going to be, because it will change based on some variable. For example, you might have a mapping, for instance. You might want to map some address to some other value. And LSP2 provides us ways of doing this. So LSP2 is the metadata standard, and this provides us ways of creating schemas, which we can use to rule sets for saving complex data types on smart contracts. And ERC725.js can handle this for us too by providing those schemas. So if you can switch to the next slide. Cool. So here, for this example, we're going to be mapping an address to a favorite food. So the example is a bit contrived, but I think it's good for illustrative purposes. But the goal is here that for every address is going to have the favorite food. So based on some address, I need to be able to calculate what the key I'm going to use is, because I need to know the location of the favorite food value that I'm going to store. So what we can do is we pass in our dynamic schema, which is what we do when we instantiate ERC725JS. So we've got the name, which is favorite food, colon, and then address in the triangle brackets. And the triangle brackets is what determines or what tells us that this is a dynamic schema to use. And we can see that the key is constructed by adding the hash of favorite food with the address. But we don't want to construct that ourselves. We want ERC725JS to do that for us, because when humans start trying to deal with bytes, they make mistakes very easily. So we pass in our dynamic key schema, and then when we encode, we specify which schema we want to use, which is in the key name parameter. So we specify we're using the favorite food to address schema. And our dynamic key parts, that's where we pass in our variables. So these are, in this case, it's our addresses, which are going to change. So we've got an address here, which I passed into dynamic key parts. And this is going to generate for us our data that we want to set on the contract. And the value of this address, so this address's favorite food is a pretzel. Go to the next one. Cool, so ERC725JS is going to calculate the keys and values that we're going to set on the smart contract based on that information I passed in. So we encoded the data. We say I'm trying to encode the favorite food of an address using this address, and the value should be pretzel. And the value it gives us back, again, is the exact same. It gives us these keys and values in this object. So now, again, this is ready and to be saved straight away on our smart contract. We can pass these keys and these values to the smart contract, and that value will be stored at that key location. So now I've saved that data. If I'm another client who wants to find out the favorite food of some address, I need to do the following things. So I need to be able to construct the key which corresponds to an address. If I have some address and I say I want to find out the favorite food of this address, I need to be able to know where I can go to find that. So I need to be able to construct that key from this address. And then I can fetch the data using the smart contract key, and then I need to be able to decode what's returned into a form which is human readable. So rather than just returning us a string of bytes, which isn't useful, we can decode that into a string, which is useful and we can display on our front end applications. Go to the next slide. So here we're going to do exactly that. So to construct the key, to find out where we need to go to find this data, we can use this function called Encodekey Name. And here this takes two parameters. The first is the schema name. In this case, it's favorite food to address. And the second parameter is the dynamic key parts. And that is corresponds to the variable, which is illustrated by the address inside the triangle brackets. So if I have an address and I want to find out that address's favorite food, I can call Encodekey Name to calculate which key I should use to query on the smart contract. And it's going to give me this in green in the comment. This is the key which has been generated for me from the smart contract that I should use to query the smart contract to get the address's favorite food. So here it's just putting it all together. Our first line, we encode the key name. So we now only know the key that I would need to use to fetch the data. The second line, we're calling get data. So we're going to the smart contract and saying, give me the information that's located at this key. And this is going to give us the encoded value. So it's not yet human readable. It's just the value that's stored at that address, but in bytes. So the third step, we need to decode that data. So we do exactly as we did in the other examples. We decode the data. We specify we want to use the favorite food to address schema. We pass in the address as the dynamic key parts. And the value, which is the bytes that was returned from the smart contract. And the result this is going to give us is an object. And you can see it's constructed in the name. It's constructed favorite food to this specific address. So we know exactly which address this corresponds to. And the value is pretzel. So now we have done the whole process, but in reverse, and we've got this value back. So yeah, that's a quick overview of ERC725JS. So in conclusion, the value of this is in LSP2, and LSP2 is giving us those the rule sets that we can use to encode and decode data, and it gives applications a common language to be able to decode things. So even if two applications can't talk to each other, as long as they know the right full rules to follow to be able to encode the data and decode the data, they can get the same information and they can exchange this information through that. So they can write to some specific key and get the data back and be able to decode it in the same way. So it allows us to easily encode and decode. And ERC725JS is abstracting all of that complexity away from developers. So in an API, which is fairly intuitive, anyone should be able to install this library in their application and start writing two smart contracts in ways that is rules that can be followed by any application. So that's that. Cool. So that's that for the ERC725JS. I guess I've not checked the questions tab, but I guess we can take questions at the end, and I'll carry on with the LSP Factory section for now. If that works.
Yeah, sorry for the echo. I didn't see the chat. Sorry for that. My bad. Yeah, I just want to add that check the docs. There are like more features. Like Callum described the main one, which is encoding, decoding, and under the hood, the lib will like check if the contract is compatible with the ERC725JS. ERC725Y. It will make sure that the decoded data is correct. If we have also fetch data, so if one of the data is a JSON URL, it will also fetch it for you and make sure the hash is correct. So there are lots of other functions which are cool. And yeah, the goal is just to make your life easier when interacting with the ERC725Y schemas and contracts. Cool.
Yeah, maybe. You have Colum and Hugo, you have one question in the Q&A, and it says, are the key parts by sequence?
I don't, yes, it's by sequence. Yeah. So if you have two, if your dynamic key has two dynamic parts, then you will need to put like the first one and the second one. So yes, I hope that was the question. There might be an example of this in the docs, but yeah, it's in sequence, yes.
Yeah, the docs have quite extensive examples for different, more specific cases than we can go over here in this presentation. This is, as Hugo said, there's other features and things that these libraries have, which you can dig into, but these are the main use cases that I think people were going to be using these libraries for. But yeah, thanks for the question. Cool, so let's dive into LSP Factory, I think. So this is the second of our JavaScript libraries, which we'll talk about today. So this library, LSP Factory, the goal here is to make it easy for developers to deploy universal profiles and digital assets with one line of code. Now, universal profiles are quite complicated smart contract orchestrations. I think they're composed of 3 different smart contracts, which is the ERC725 account, LSP6 key manager, and LSP1 universal receiver delegate. So most developers are not going to want to have to figure out how to deploy these things and hook themselves up manually. They want an easy way to deploy universal profiles in their application with just an easy one line of code. And this is what the goal of LSP Factory is, and the same for digital assets. And not just that, but we want to be able to configure these universal profiles so that when they're being deployed, we can hook up metadata. So when you're deploying a universal profile, you can deploy it with some profile picture, some background image, a name, description, that kind of thing. And LSP Factory is going to do all of the work of actually setting this data and encoding it correctly and setting it on the smart contract so that it can be readable and fits with the relevant standards so that other applications can then pull that data and read it. And it also lets us deploy custom implementation of these contracts as well, which I will discuss later on. Cool. So this, to set up LSP Factory, we need to instantiate it with a provider and a chain ID. So our first line here, we just call LSP Factory equals new LSP Factory. Here we pass the window Ethereum object and the chain ID. Now, so something to note is that these examples here are going to be as if LSP Factory was being used inside a browser. LSP Factory also works in a node in a backend environment, but the setup would be slightly different. So we don't have the window Ethereum object in a node environment. So here you would pass a RPC URL, and instead of chain ID, you'd need to pass a private key of some address which had some funds, because that's going to be the address which is making the transactions. But here, when we use it in a browser, this is going to prompt a user to make these transactions. So it's going to be the user of the dApp where this code is called that's actually going to be sending these transactions from their account. So we instantiate LSP Factory, passing the window Ethereum object. The window Ethereum object is the same for both MetaMask and Universal Profile browser extension, which we have. So your dApp can support both of these things. Both work fine with LSP Factory, and it's interchangeable. LSP Factory doesn't care which one it is. So it's just something to note that you can use both, and it will work exactly the same. And then in our second line, we call lsp-factory.universalprofile.deploy. And in our configuration parameters, we specify a controller address or an array of controller addresses. And these addresses passed here are going to be set up so that those are the addresses which have permissions on the universal profile in order to make transactions for the universal profile. So those are the addresses which are going to be able to set data on the profile or make a transfer some token from the universal profile or whatever. But this, as it stands, this is the most sort of basic setup of LSP Factory you could have. The profile there is going to be a bit bland because there's no metadata set on it. So to deploy a universal profile that has some metadata, we pass the lsp3 profile parameter. So here we can see a passed lsp3 profile, which is the key of it, which is an object. So we're passing in a name, a description, an avatar, which is a like a 3D avatar file, and profile image. And this data is going to be encoded by LSP Factory to adhere to the LSP3 profile standard. So if you set this on some profile, another application could read that data, for example, using ERC725 and that application would get all of this data which you set on the smart contract. And here, for example, the image and the avatar files, these can be JavaScript file objects in a browser. For example, if you had a HTML form, for instance, with some file inputs, you could pass the input, the values of those file inputs straight into LSP Factory, and LSP Factory will do all the processing. So it'll upload those files to IPFS, it will resize the images and construct the JSON correctly. And the exact same idea applies for when deploying digital assets. So when deploying an LSP7 digital asset, which is our token contract, there's a few more parameters here. We have one controller address this time instead of an array. We have our constructor parameters as well. The constructor parameters are isNFT, symbol, and name. And those are the constructor parameters which are going to be passed to the smart contract during the initialization of the smart contract. And as the last parameter, we've got the digital asset metadata. And this behaves exactly the same as the LSP3 universal profile metadata, where we pass all of the fields we want to include in the metadata, so description, an icon, which is going to be an image file, and that's going to be processed by LSP Factory and attached to the profile. And there's more options of which fields you can add. Again, I would advise looking at the docs to see the full extent of what could be passed. And finally, we've got LSP8 digital assets, and these are our NFT contracts. So these you can think of, they've been inspired by ERC725. And the fields are exactly the same as the LSP7 digital assets, except there's no isNFT constructor. So that's the only difference here. So I think for most use cases, that's probably going to cover the extent that you would need LSP Factory for. I think for most people are going to be deploying universal profiles and smart contracts and just want to attach some metadata and be able to use it, in which case what we've discussed is all you need to know, but we can go further and we can do some more complicated stuff. So we can now start getting into more of the contract customization that you can do with LSP Factory. So to start, LSP Factory, when it's deploying these smart contracts, it uses something called minimal proxy smart contracts. I'm not going to go into too much detail with this here. This is a standard of smart contract deployment, which basically enables us to deploy quite cheap contracts by deploying very lightweight contracts with not very much bytecode, which defer their logic to another base contract. And the base contract contains the logic of how the contract should behave. The proxy contract defers to it. And this means that the deployment of LSP Factory is going to be cheaper. And it also enables LSP Factory. It means we can do versioned smart contract deployment by storing different base contract addresses which correspond to different versions. So, for example, here we have in our second parameter, when calling universal profile.deploy, we can specify the version of each individual contract. So here in this example, we're saying the ERC725 account contract should use version 0.6.1. And what this tells LSP Factory to do is it says, use the base contract which corresponds to this version. Inside the LSP Factory stores different base contract addresses, and each of those corresponds to a different address. So when each of those corresponds to a different version. So when a different version is passed in, the library knows to pick out which base contract to use when deploying the proxy. And this also means that if you, for example, wanted to deploy a custom implementation of a contract, you could pass a base contract address to the version. So when you pass an address to the version, you tell LSP Factory that you want to deploy a specific contract using a specific base contract address. So here we have a LSP6 key manager, and the version will be specified a base contract address. Now, this can be your own custom implementation. For example, if your use case requires that your version of key manager needs an extra function, which is your special function, it can do anything, then you could deploy that base contract and you can use that base contract address, pass it to LSP Factory, which now means you can easily deploy many of these universal profiles which use that same version of the LSP6 key manager, which means you can deploy many of your custom implementation of that key manager. And because it's using base contract and proxy smart contract pattern, it means that it's going to be a cheaper deployment for each one of those instances. We switch to the next slide. And similarly, we can do the exact same thing, but with bytecode. So if you have written a custom implementation of some contract, and the custom implementation, for example, you've got your own special function that you need for your use case, you can compile the Solidity contract which you've written, you can compile that down to creation bytecode and pass that bytecode into the LSP Factory. And now when LSP Factory is deploying the universal profile, it will deploy your bytecode and use that as the LSP6 key manager. Something to note when doing this, so when deploying using custom bytecode or when using a custom base contract address, is that the standard it's passed into must always meet the relevant standard requirements. So in this case, the deployed bytecode that's being used to deploy the key manager should always meet the requirements of the LSP6 key manager standard, because otherwise it's a different contract entirely and it's not going to fit together with the universal profile. But you can absolutely add new functions and new functionality on top of the standard, but it's got to meet that standard as a requirement. So, and the last feature I'll discuss just now about LSP Factory is this reactive deployment. So what we've been discussing is deploying these smart contracts for the universal profiles and digital assets from our browser, from the front end. Now, to deploy a universal profile, there's a few transactions involved. There's 3 smart contracts, which I've described, and each of those smart contracts needs to be hooked up in a certain way. And that each of those steps takes a transaction to be able to set that up. So as good developers, we're always concerned with good user experience. So when we're building our dApps, we want to provide good user experience for users who are deploying their universal profiles and digital assets. So we want to provide good feedback to users as they're confirming these transactions to let them know what's going on. So we can switch to the next slide. So here what we can see is the way we achieve that is we can pass these deployment callbacks inside the onDeploy events parameter in the deployment configuration. So there's 3 callback functions we could specify. There's next, complete, and error. Each one of these, you can go back, yeah. So next is going to be called every time there is a deployment event emitted. So the next callback can be called multiple times throughout the deployment life cycle. There's a deployment event fired whenever a contract is deployed or whenever a transaction is sent to the blockchain. So it's going to be called multiple times. So for instance, here you could have some configuration and in your callback, you could set it so that it triggers a loading bar increases, for instance, or some kind of user feedback to let users know that it's progressing. And our complete callback, this is going to be called once after deployment's finished, and it's going to return to us all of the contracts which were deployed from our so that we can tell the application what to do with the error should it occur. Cool. So I think that yeah, that covers it for the JavaScript library side.
Cool. Yeah, thanks, Callum. If you guys have some questions about those like npm libs before we switch to different topics, I see there's one questions related to is LSP Factory armored and verified. This one. So at the moment, the package was not like audited. It's we're still like in beta and stuff. So we tell developers to like not use that in production. And we are currently doing security audits to the smart contracts. So that's the first step. And then we will like audit all of our tools, including the extension and this, before like going into like mainnet mode and like, okay, everything is ready and just use it. So we'll have like a stage where like this thing will be audited. We are still in the beta phase somehow. So yeah, I hope it answers the questions.
Yeah, another thing on that is the base contracts which are used and stored inside the LSP Factory are always initialized to a null address. So those basic contracts couldn't be taken over, for instance, because they don't own, no one owns them. No one can ever make any changes to those base contracts. So any proxy contracts which was deployed and defers to those base contracts, it's going to be stable.
Okay, cool. Yeah, let's switch to the Relayer API. So this is fairly easy after the things that Callum presented. You will see it's super easy. So again, you can see some information on the docs. So we have docs.lukso.tech. And also there is like the Swagger documentation of our like L16 relayer. So you can go on here and check the different endpoints. So only one is really interesting for you is the execute endpoint. And we'll go through this one. So the idea is like extremely simple. It's just a backend that will call the execute relay call function of a key manager. So it's just as simple as that. And the idea is that you create a transaction, but you don't pay for it. So you create like somehow like you take an envelope, you give it to us, and we put the stamp and we put that to the post. So this is basically what the execute relay call does, and it allows us to us and also like other maybe companies to pay for the transaction. So we believe that it's a really nice addition to the ecosystem because like users, they don't really have to create an address, register KYC, and do all this stuff on an exchange, send money, and then send this to their account. Like here, your app can just call a relay system, or even the people can maybe pay for a subscription, similar to like when you pay for your data for your phone. And yeah, you just have access to this execute endpoint, and you just send transaction, and the transaction will just be executed on your behalf, and you won't pay for it. So it's pretty cool. So you can check again in the docs here in the standard, you can see like how it works. And this is how it works. So basically you send a post request to a /execute endpoint. You put the key manager address. So that's the key manager you want to use. And here you put your transaction. So your transaction needs to have the ABI. So the ABI is the encoded transaction that you want to send. So it can be anything. Of course, the transaction should be valid. If it's not valid, it will revert in some weird way. A bit hard, or like harder than if you would execute that directly. Jean and Yamen spent a lot of time trying to make those errors like as helpful as possible. But yeah, that's something maybe to know, that it's a bit harder to see what went wrong when you send the transaction through the relayer. And then you need to put a signature, of course, and a nonce. So the way our relayer works is that it will like give you back the information that you send, key manager and transaction, and it will add the task ID. So then with this task ID, you can query the relayer and see if the transaction has been executed and get some more information. We want to, like, those endpoints are not fully standardized yet. We want to work on this and maybe like have like a broad discussion with the community and see like how we can make this thing standardized and yeah, well made. We want, for instance, that the task ID is like, we want it to be the transaction hash. That would makes it like slightly easier. So when you send your transaction, you get the transaction hash back, and then you can query the information with the transaction hash. So the way you need like to create this transaction is like maybe not super straightforward. The idea is that first, if you want to interact with a universal profile, you need to get the owner. Like you need to find a key manager, because this works only with a smart contract that has this execute relay call function. So for instance, a key manager. So once you have the key manager address, you need to call the get nonce. And the get nonce will get like this, those parameters where you can say, okay, that's me, and I want to get a nonce, because maybe multiple apps will want to talk to your key manager. So it's not like getting a single nonce from a single like EOA as we are used to do. So we have those channels. It's written in the docs, so if you want to see how it works. And yeah, so there is this kind of nonce thing. It will be like easier if you check the docs, but the idea is that you get a nonce similar to how you do with an EOA, and you sign your transaction with this. So then you create the transaction that you want to execute. So here it's an example with set data. It can be anything. It can be a transfer ownership. It can be like whatever you want, whatever is available on the final contract, the one that is being owned by the key manager. And the important thing is that at the end, you need to do encode ABI. This is how you get, if I go back, this is how you get this ABI here. So you encode this ABI, and you've got your ABI payload. And then once you have this, you need to sign. So you will sign the whole transaction with the key manager, the nonce, and the payload. And yeah, then once you have your message, like you've got the signature and you've got everything you need to send your payload to the relayer. So yeah, you've got the nonce, the payload, the signature, and you can just send that to your relayer, and you will execute the transaction. And the good thing here is that you don't have to pay. So here, you see here you are signing message here, controller account. This controller account may not have any token and like any money, and it will just work because you won't pay for that. So yeah, that's the thing. And then you can send the post and get the task status. So it's that easy. We are working hard on making that layer like next level in some ways, so to have some authentication, quota systems and stuff, because yeah, otherwise it won't work so long. But yeah, you can use that. You can give it a try during the hackathon, see how it works, try to encode your transactions, and yeah, have your transaction being sent from a different account than your own account. Cool. So let me go. Yeah.
One thing just on the relayer is that this implementation of the relayer, it was like version 1, let's say. It's not compatible with the relayer standard specification that has been that's in the. If you were looking to follow the relayer track of the hackathon, don't copy the API of this relayer. This is like version 1, and the new versions will use the standard doc, which is in the description of the relayer track. So it's just something to note that this as a tool is useful if you're building an application where you want to consume a relayer service, for instance, rather than something to base your own relayer service off.
Yeah, good point, Callum. And if you want to build a relayer, you can like make it in any way you want. And on your backend, you would need like to instantiate a key manager contract, get the payload from the API, and make contract.method.execute relay call. And then you can do whatever, like you can make sure that the transaction is valid. You can queue that. You can, you can be creative. But the core piece is that easy. It's just about taking the payload that you get from something, and send it through the execute relay call. So on our side, we are like making everything around. So creating user accounts, trying to optimize this so it can scale. So using multiple keys, improving the nonce management, not from the client side, but from the backend side, because when we have multiple keys, we want to make sure that our nonce is being used in a correct way, because if we use the same nonce to send the same transaction, like multiple transactions, it won't work. So those are like the kind of challenging things about building a relay system. Also, there are things related to monitoring, security. So we think it's kind of cool. So yeah, you can take a look at this. Cool. Let's go to ERC725 Inspect. This is a really, really easy tool. I will show that later in the demo, but the idea is that you go to that website, ERC725inspect.LUKSO.tech. The idea behind that, if I go way back into this screenshot here, so this is an example from Bloxcoot when you click on read contract. And that's how we used to debug at the very beginning. And for this to work, the contract has to be verified, which is not always true. And then we'll see like, okay, the key is here. Okay, let's get the key. And then like, it was very, very, very annoying and time consuming. So then we were writing our own scripts. So even if the contract was not verified, we could still like get the keys from our own scripts. And then it just like turned out into like just a simple front end where you put your ERC725Y compatible smart contract address, and you get a bunch of information about the keys. You can decode that live, and yeah, a bunch of like other help functions. So it's cool because you will see those stuff are like not so easy to debug, because yeah, it's you're working with smart contracts, so you maybe already know that's not super easy to debug. So yeah, that's why we built that tool. It's very easy. It might not be perfect, but it's a very simple way for also among us, like just to see, oh, you have an issue, give me the smart contract address, and then we can check very quickly, oh, the key is here, the key is not here. So it's a nice tool. So just make sure that you know it's here, and yeah. Cool. So that's it for the tools. And as as Nils said, talk is cheap. It's cheap. Show me the code. So we'll try to make some code and show you like a bit of those tools, how it works. And yeah, there will be maybe a good way to see if it works. So let me share my screen. So I will share my whole screen here. Give me 1 second. Yes. I need to share. Yeah, entire screen here. Share. Okay. Okay, cool. Can you tell me if you can see the screen, if it's working?
Yeah, it looks good for me.
Okay, cool. Thanks. So yeah, so the idea is that this is this repo. It's a very simple repo. It's available on GitHub. It's on the docs, so you can check. But the idea is just to show you like how to init a project and have the basic things. So there is a README that you can check. So just setting up the project, installing the libs. So here we are installing ERC725 LSP Factory Web3. Also here it's TypeScript project, but you may not want to use a TypeScript. It's up to you. But yeah, just having everything ready so we can have a very simple script. So the first script is about generating a wallet and adding found to it. So it's as simple as so if it's a front end and you can inject the extension or the UP extension or MetaMask, it's okay, you don't have anything to do. If it's something that is on the back end, you may want to just create an address in some ways. So with Web3.js, you can just do eth.account.create, and you will get an EOA with a key. So let me execute that. TS node and 01 here. So this will just generate an address. So you can see here I have my private key, so never use this one again, but that's the idea. And then the thing is that you need to add fonts because we will deploy some stuff from that key. So you need to add some fonts. So you can do that by going to the faucet, the LUKSO faucet. So it's an authenticated faucet because otherwise people will just take too many tokens. So just make a tweet with this address, and you just put the tweet address here, and then you click on give me lux, and you will get some lux. So I did that yesterday, and you see here I've got my lux transfer here. So of course it's a different address because here the script, every time I run it, I will get a new address. Then the idea is that you put your private key into the .env file. So here it's an example private key. So you put the private key that you have here in your .env file, and then that's the account that we will be using in the other contracts. So now deploying a UP. So this is a cool part. So here we will be using LSP Factory. So as Callum described, and as you can see in the docs, we just set it up. So we need to have an RPC endpoint. So here we're using the, see here the LUKSO L16. We are using our private key here, so being loaded from the process.env, and then we add that key in, we add it in the Web3 account, so we can factory.universalprofile.deploy, and we want to set this key, like this address that I just generated, as a controller address. So and we want to deploy a profile with some name. So let me deploy a new one. So let's say hello. Okay, very amazing. Hello, and let's put the time is 10:55. So yeah, that's the idea. We want to deploy that, and here we are using the deploy event so you can see what's happening. And let's run this. So let me clean this. Okay, let's start this. So you see, on my side, it's just one line. It's really nothing much to do. Like I just say that I want to deploy. And you see now cool things are happening. Like this is the cool part. We can also go on the block scoot. And let's see here. We should see some stuff happening. So you see here that we are creating some accounts. So you see the LSP factory is working. It's deploying contract. So yeah, the logs are very low level, but you see here, we have deployed the account. So it's this transaction. So now the next thing is about initializing this account. So you see this transaction is now successful. So we should see here complete, amazing. Now we have another transaction, which is like the key manager. So we want to deploy through the proxy, the key manager. So here you see that it's pending. Let's see, it's waiting. Complete. Yeah, we have some delay with the blockchain explorer. It's slightly behind. So you see here, contract call, contract creation, like all of this thing is happening. And as you can see, this is a lot of steps. Like it's really not so easy. And that's why we created LSP Factory. So you see, like it's still setting up everything, connecting the dots. You can see here, if you go in the standard here in the key manager, it will show you how this thing is connected. So you see, it's doing all of that for you. And you see, it looks like it's over. Transaction, yes, okay, wow. Done, complete. So we are good. Oh, okay. Yes. Oh, wow, it's still, okay, done. So now we have a lot of things. And yeah, the final thing is say, okay, this thing has been deployed and that's the address. This is the address of your UP. And now we can use, and let's use the ERC725 Inspect and see what we can see. So I'm using L16. So the L16 is here. And let's inspect that. Yes, so we can see that is a ERC725Y and X compatible smart contract, and we can see that those keys have been set up. So you see, it's very nice to see like, okay, those are like all the things being attached to my profile. And you can see that here we've got the LSP3 profile. So it's an IPFS. And let's see what's behind. And you see, those are the things that, oh, wait, this is not the correct one. I don't see the time. So maybe I'm reading the previous contract. I don't know. Wait. Okay, maybe let's do like this, contract creation to F. Yeah, which contract am I going? It's this one. Let me see. Here. I don't know. I think I messed up with the contract address, but you get the ID. And we can also go here on the L16 universal profile and put the address here and see how it looks like. So yeah, we have a new address. Oh yeah, I know. It's because I didn't save my file. Yeah, I didn't save. So yeah, I have to start again. But you get the idea, right? So here's our contract, and everything is set up with a very few lines. So that's super cool. So that is LSP Factory, and you can do the same with tokens. You can do the same with yeah, some stuff. So it's really cool. So yeah, LSP Factory, that's how it works. And now let's go to the ERC725JS. So now we want to read the information from the from our smart contract. So let me put the address here of the contract that I just deployed. And as you can see, I'm loading LSP3. So if we go in the schema here, we've got all the basic keys that we want to, query from an LSP profile. So we have a couple of keys here. We init the lib with the, let me maybe close this. So yeah, we create a provider with our RPC endpoint. We give an IPFS gateway. This is used for the fetch, because when we fetch, the lib will download the JSON for you. So we need to say from which IPFS gateway it needs to be downloaded. Yeah, so we init the lib, we say the UP address, or like the ERC725 contract address, but here it's a UP, so let's call it UP. The provider and the config, and then we just do this. So I will start with get data. That's easier here, and I will run that. So npx, yes. Okay. Okay, cool. So you see that the lib has queried all the keys for me, and yeah, it has decoded everything. So we can see that we've got all our keys, and it's super handy. The only thing we don't have here is that you see here the lsp-free is like, it's just the URL. If I'm using fetch data, I will get the whole JSON. So here I can replace that with fetch data. So only one thing is that I need to install polymorphic fetch. I didn't install it because I polymorphic fetch. Because okay, I don't.
There's isomorphic.
Oh, yeah, isomorphic. Thanks. I don't know why I was with polymorphic, and maybe it's a new kind of stuff. So thanks, Callum. And let's install this here, isomorphic fetch, because we are using this on the back end and it's using fetch, so that's why otherwise it won't work. Okay, so now it should be working. So let's install this. Let's run it again. I save this time here, and let's start. Oh, it doesn't work. Okay, I don't know why. I didn't set it up properly. Okay, I won't. I don't know why. Wait, let me check. Yeah. I need to. Yeah. I know. I need to import it. Yeah. Require. That's why. Okay. Sorry for this. Here. It's require. That should work. Let's try again. Yeah, we will make this more clear in the docs. Okay. Well, it doesn't work. Oh, it's not .network, it's .tech. Yeah. Okay. Yeah, I don't remember what is our IPFS here. Dev. Sorry for this. Okay, here, and then hopefully this is the good time. Yes. Okay, cool. Oh, okay. So you see here, it's an object. But yeah, the idea is that it gets the information from our like the real file. So yeah, that's basically how it works. I won't go more into like doing more things. This is really the basic things, but this, like, we can, as Callum showed, we can update the keys, decode the keys. You can show that in the front end. That's how, by the way, that's how this ERC725 Inspect works. It's only using ERC725JS under the hood. So we're just like putting that on the front end. It's open source, so you can check here on GitHub and see how it works. It's really not that hard. Yeah, it's just we are mainly using ERC725JS. So yeah, that's it for the code. I will push that the latest version, And yeah, I hope that, let me stop sharing. I hope that you learn stuff. I think for our presentation, let me go back to our presentation here, share Chrome here, tools, share. Okay, cool. And yeah, that's it. So if you have some questions, I see some stuff in the chat. The Explorer is much more than no, yesterday was more behind, like it was more like 1 hour behind. The node has been restarted. So yeah, this might be a bit annoying. Sorry for that. Yeah, sorry for this. Yeah, if anyone, I see there's a question here. Any examples on how to use LSP9 and 10? No, sorry, not yet. But we can, this is like the thing that we don't really have tutorials on, not yet.
These standards are a bit newer, I think. So in terms of the libraries, some of the libraries haven't really caught up yet. So in the future, LSP Factory will deploy these things for you as well. So you will be able to do lsp-factory.lsp11 Volt, I think it is, and deploy a Volt or whatever it might be. But just at the moment, this hasn't been implemented yet. But yeah, these new examples and new use cases will keep coming as we build out.
But for that kind of things, Jeff, for instance, go to our like Discord and ask. We want to take more like in our sprint, like sometimes like, okay, what are we missing from our docs and from, let's say, our personal experience and from the community, and we want to focus on like adding the docs that are the most relevant. And we spend some time, like over the last months, we changed a lot the standard, so we updated the docs a lot. Now it's good, and now we can focus on like making new ones. Hopefully everything you see on the docs is up to date. We did a lot of reviews, so that's hopefully good. And now our next steps is to add more docs, add more example repo, example apps, different languages, different framework. So yeah, that is our goal over the next weeks and months. So yeah, if you have specific questions and specific things that you miss, ping us in the Discord, and we'll like see, oh wow, there's interest for that kind of topic, so we will put focus on it. Cool. Yeah, I don't know, Jonathan, if you want to add something, or Gloria, but yeah, cool.
There's one more question in the chat, so if you can answer it.
Cool.
And it's, is universal receiver delegate available as an example yet, or permissions user for receiver?
I'm not sure 100%. So I think there are some examples about universal receiver delegate. I'm not sure about the permissions used for receiver. So the universal receiver delegate needs permissions on the universal profile to work properly. So when the universal profile is being deployed by our relayer and by the LSP factory, the universal receiver delegate is given the set data permission. The reason being that it updates the received tokens array when a token has been received. So the universal receiver delegate does have permissions set on the universal profile. I'm not sure if that answers the question.
Yeah, I will also show. I mean, that's a good point to show something. Let me. Sorry, I will share again my whole screen. I will just show you quickly here, screen here and here. Okay, cool. I think it works. Callum, can you confirm that you see my screen, please?
Yes, I see it.
Okay, cool, thanks. So if you go in the extension here, and you see this is a profile that has been deployed from the extension by using the relayer, by the way. And the relayer is using, it's not using LSP Factory, but it's doing things like very similar, like it's setting up everything. And you can see that on a fresh deployed profile, you have this browser extension, which has full control. And then you see that you have one new key here, your controller, and it's your universal receiver delegate. And here you can check the permissions. So you see that the only permission it has is the set data. So yeah, it's a way to see the data. There is no whitelist at the moment. It has full access on setting data. And we can check, I think, like if we use the inspect here, let's do this. ERC725, you can read the permission. So let's check here. So you see here, yeah. So for this case, we would need to query a specific key. So here we go to get data, contract address, and then we want to check the permission. So address permission for this address. So let me go into this address. Let me find it here, copy. And here I put the address without the OX, and let's check get data. And you see that it has a permission, which is like 8. And this is not very helpful, but we can go in the key manager here and put that permission there. And you see that it's decoding the permission, and you see that it's only set data. And here that's the array. You see it's false everywhere except for the set data. So it's a way that you can check some information by yourself. And yeah, and we can see, for instance, like we can query it's not as automated as we want to do, but we're adding features, but still we can see the information. And yeah, so at the moment it only has one permission. I hope it answers the questions. Stop sharing. Yeah. Cool.
There's another question too. Will there be any append method for the ERC725Y compatible array? And this is kind of what you were just showing, but with set data, we basically rewrite the whole array, which can increase gas fees on each append.
I think when updating the array, you shouldn't need to update everything in the array. If we're talking about the LSP2 standardized array saved on an ERC725Y contract, you should only need to update the length of the array and the value that you're adding to the array. So you update the length of the array, which is the value, which corresponds to how many items are in the array. And then for the array with the index, you add your new value. And I believe that's all. Everything else in the array should be unchanged. So when you add something to an array, it should just be 2 values that are being updated.
Also, if you want to remove something from the array, that would be maybe a question for Jean and Yamen, because there is some logic that will adjust the keys in a smart way, so you don't have to, like move everything back. But then maybe for that, it's better to ask them. But there should not be reason to update everything, and the append should be just like, hey, you want to encode a new key, and the thing will give you you should update here 2 things, the array length and the last key. And the thing will like give you 2 keys, 2 values, and you just send this thing, and it should be good.
Perfect. I don't see any more questions in the chat or the Q&A or the live stream either. So perfect. So with that, I will go ahead and say thank you to Hugo and Cullum. That was extremely helpful. And if people do have questions when they're watching this, again, is it best just to reach out via Discord, or what's the best way to follow up?
Yeah, Discord is good. We've got, there is a channel specifically for the hackathon conversation, for developer questions for the hackathon, and there's also dev channels for standards as well. So you can ask in there. And yeah, we try and be active in there and reply to questions. And also any feedback on documentation and things like that. And the tools themselves is always appreciated. yeah, so we can know what to work on.
Yeah, and
Awesome.
also for our like everything that is open source, you can create a GitHub issue. And for the things which are not open source, we created a issue tracker repo where you can add an issue and the whole team is watching it. So the whole team will get an email if you create an issue. And also that's something that will be taken into our sprint planning so we can fix stuff. So yeah, that's basically how we work. We try to be active on the Discord. We are based in the mainly European time zone. So if it's like 5 a.m., 3 a.m. in Europe on like, a Saturday morning, maybe we won't be able to
Yeah, I
answer
won't be
that
answering.
fast, but still, I think we try to do our best. So yeah.
Yeah, but we always like go back on Mondays and check what's happened through the weekends as well. So we will aim to get back.
Perfect. And this is just a reminder, tomorrow we have another session at the same time about building basic dApps on LUKSO. So if you want to join us tomorrow, that will be happening as well. But I would go ahead and get started with your application and bring any questions that you have. Just reach out to the team. It seems like that's the best way to do it. So once again, thank you so much, Hugo and Cullum, for your time. I really appreciate it. With that, if you have no more last words, I'll go ahead and close the session. If not, I'll give you a moment.
Cool. Yeah. Thanks everyone. Thanks, Callum.
Thanks for
sorry
joining.
for the sound issue at the beginning. I'm on the way and I don't have an extra monitor, so I didn't see the stuff. Super annoying. But yeah, that's that's how it goes. Sorry for that. Cool. Have a happy hacking, everyone, and we are available if you need. So thanks.
Yeah.
Thank
Happy
you.
hacking, everybody. See you next time.